Actually, this is TG. Okay. Which will, when it is on, it will transfer the logic. When it is on, it will transfer the logic. It will transfer whatever is there at its input faithfully. Okay. But now the question arises. In previous class, I said it just multiplies and changes them. Okay. Whatever you have written in previous class, you just modify it because theoretically that answer is also correct. Even perpetual law, that is theoretically correct. Okay, logically it is correct. But actually TG practically ಏನು ಮಾಡ್ತದೆ ಅಂತ it will multiply the input with the signal which is present at the gate of NMOS. So if here I have S bar, here I will have S, because generally TG ಒಳಗೆ ಏನು ಮಾಡ್ತೀವಿ, one gate of PMOS or NMOS, okay, one we have 0, the other will be 1, or if here I have 0, here it will be 1. That convention we follow. Okay, so here, if here I write S bar, here it will be S. Yes, andre here it is also S, here it is also S, and here it will be S bar again. Okay, so TG what it does, it will multiply the input into signal present at the gate of NMOS. Yavaglu. So here it is multiplying A into S bar, B into S. Both are being added. Okay. Whatever reason you have written, that is also correct theoretically, but practically if you do it in the lab, okay, you may get some changes. And actually it depends on what logic you apply for S and S bar also. 0, 1 or 1, 0, that also depends. Okay. But this is the actual design. In previous class I gave you some homework. Anyone has done it? Homework ಏನಿತ್ತು? ಗೇಟ್ಸ್ ಯಾವ್ದಾರ ಒಂದು ಗೇಟ್ ಟ್ರೈ ಮಾಡಿದ್ರಿ? ಯಾರು ಟ್ರೈ ಮಾಡಿದ್ರಿ? ಯಾರು ಟ್ರೈ ಮಾಡಲಿಲ್ಲ? ವೆರಿ ಗುಡ್. ಒಂದು ಗೇಟ್ನ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ ನಿಮ್ಗೆ. ಓಕೆ, ಒಂದು ಗೇಟ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ. Say 2 input NAND gate. 2 input NAND gate. How we have to design this? First we have to write the truth table of that. So A, B, Y 0, 0, 0, 1, 1, 0, 1, 1. Answer. Two input NAND gate table answer ಹೇಳ್ರಿ. 0, 0. So whatever I have got this I will plot it in K-map. So one K-map ತಗೋತೀನಿ. Okay. ಆ K-map ಒಳಗೆ I will write these values. Say this is A or anything, B or A, anything. 1, 1, 1, 0, 1, 1, 1, 0. Okay. So let me take this as B. This as A. Okay. So here, if you take this one, the first input will be 1. 1 ಮತ್ತೆ 1 ಇದಿದೆ. Okay. So here, let me take A and B like this. Here. So 0, 1, 0, 1. So ಇದು ನೋಡ್ರಿ, ಇದೇನಾಯ್ತಲ್ಲ, when B is 0, I'll get 1 here. When B is 1, ಇದು ನೋಡ್ರಿ, ಏನದ ನೋಡ್ರಿ, output is 1 when A is 0. So for this I get A bar. 1 and 1, definitely it is 1. Here it is 1 and 0. Okay. So 1 and 0 is like 1 element only. For A bar, A0 is like 1 1. So I will take A bar. These will be the inputs for that gate. So the input will be 1. Here it will be A bar. Okay. Ignore it. And the other will be B bar, B and B bar. Innone signal yav deti A matte B. So I will take B as select line and input I will take it as A. Okay. But here I am A bardilla nanu because I am getting 1 and 1 anta I will get only 1 only. If it was 0 matte 0, il 0 barittidri. Okay, the first input would have been 0 if I had 0 and 0. Correct? Suppose ಇಲ್ಲಿ ರಿವರ್ಸ್ ಆಗ್ತಿತ್ತಂದ್ರೆ ಇಲ್ಲಿ 0 ಇರ್ತಿತ್ತು ಇಲ್ಲಿ 1 ಇರ್ತಿತ್ತಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಬರೀತಿದ್ರಿ ಇಲ್ಲಿ 0 ಇಲ್ಲಿ 1 ಇರ್ತಿತ್ತಂದ್ರೆ ಏನು ಬರೀತಿದ್ರಿ A ಬರೀತಿದ್ರಿ ಯಾಕಂದ್ರೆ 1 is present when A is 1. If A is present then I have the output. So ಈ ತರ ಡಿಸೈನ್ ಮಾಡ್ತಾರೆ. So here from this K map I got what should be the input at both the TGs. If I take this control signal ಹೇಳ್ತಾರೆ or ಕೆಲವು select line ಹೇಳ್ತಾರೆ. Okay, you tell whatever it is. If you take control as B, then input will be in terms of A. So here first input is 1 from K map. By observing we can see. Okay, here second input is A bar. You know it is A bar. Okay, so 1 and A bar are the input. If I take B as the control input, so here if I take B bar, B bar, okay, then first input is 1, second input is A bar, and as I said, you just multiply 1 into B bar plus A bar into B, and here you get 1 into B bar as B bar plus A bar into B, and this is direct equation as per this. This is one law. Okay. And what is this actually? What is this actually? A dot B whole bar, D Morgan's theorem. A dot B whole bar ಏನು? A bar plus B bar. So ಇದು ಏನಿದೆ? ಯಾವ ಗೇಟ್? ಯಾವ ಗೇಟ್? NAND gate. We started to design NAND gate and we have designed NAND gate using TG. So except inverter, except NOT gate, everything can be designed using TG. Because TG won't invert the signal. TG will pass the signal as it is. Therefore, we can't design the NOT gate. The other day, one good question was asked. Okay, so except NOT gate, all the gates, all the circuits can be designed using TG. But you should know the logic. The logic I have said you. Given one simple example. Okay, this will not be asked in the exam, but it may be asked in any of the interviews. If you say yes, I know TG, then next question they will ask what is TG? Okay, design something using TG. Right? Next we will design D flip flop using TG. D D flip flop using TG. I think you have written the title as memory. Under that, you can write down D flip flop using TG. D bar. This will be LD bar. This is D flip flop using PG. This is inverter or NOT gate. So the same NOT gate which we studied in previous class. Next question what you should ask is prove that it is D flip flop. So LD then is a protein law. You can change the name also. Not just LD and protein. Clock kodabodu. You can write clock. Or it is control signal. It is simple control signal to turn on the TG. So this is TG1, this is TG2, this is inverter 1, this is inverter 2. You remember query? Pens down. Now make explain one thing, I will type proceed. See, if LD is 1, what will happen? This is TG. Are you able to recognize it? This is input, this is output of TG. This is N MOSFET. This is N MOSFET. This is P MOSFET. Okay. So if LD is 1, what will happen? TG. If LD is 1, what will happen? TG1 is on or off? Is on or off? It is on. Why it is on? Because 1 is going to gate of NMOS and LD bar is 0. So 0 is going to gate of PMOS. Both are on. Therefore TG1 is on. Okay, TG2, 1 is going to gate of PMOS. Off. Here also off. So TG2 is off. Fine. This is on, this is off. This is off means there is no connection. No connection. Open circuit. Okay, no connection between this point and this point. So whatever signal I give D flip flop means it is data flip flop. Okay. That signal will pass through TG it will pass through inverter. So iದೇನಾಗ್ತದೆ D ಬಾರ್ ಆಗ್ತದೆ ಹೌದಾ ಇಲ್ಲ ಇಲ್ಲಿ D ಕೊಟ್ಟು D ಗೆ ಇನ್ವರ್ಟರ್ ಪಾಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ D ಬಾರ್ ಆಗ್ತದೆ ಅರ್ಥ ಆಯ್ತು ಇಷ್ಟು ಕ್ಲಿಯರ್ ಆಯ್ತು ನೆಕ್ಸ್ಟ್ when LD becomes 0 at this point your D bar will be stored or will be present at this point. This point is that D bar store ಆಗಿರ್ತದೆ means what? It is present unless and until I change it, that one logic 1 will be present here, or logic 1 or 0, whatever it is. Okay, now D0 ಕೊಟ್ಟಿನಂದ್ರೆ ಇಲ್ಲಿ 1 ಸ್ಟೋರ್ ಆಗಿರ್ತದೆ 1 D0 ಕೊಟ್ಟಿನಂದ್ರೆ D bar ಏನು 1 ಅದು 1 ಇಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿರ್ತದೆ ಈ ಪಾಯಿಂಟ್ until and unless you change it, that 1 will be present here. This is what storing. ಇದೇ ಸ್ಟೋರಿಂಗ್ ನಿಮ್ಮ ಮೊಬೈಲ್ನಾಗ ಇರ್ತೈತಿ ನಿಮ್ಮ ಇಮೇಜಸ್ ನಿಮ್ದು ಫೋಟೋಸ್ ಸಾಂಗ್ಸ್ ಇದ್ರ ಬಗ್ಗೆ ಹೇಳ್ಬಿಟ್ಟಿರಿ ಹಿಂಗೆ ಸ್ಟೋರ್ ಆಗ್ತದೆ ಡೇಟಾ when LD is 0 what will happen you people tell if LD is 0 DG1 is off DG2 is on so this is off means no connection. But here there is a connection because this is on. So next what will happen? This signal D bar will pass through one more inverter. So what it will become? It will become D double bar, that is D. So Q equals to D. This itself is your D flip flop. D flip flop ಏನು ಹೇಳ್ತದೆ? It is data flip flop. Whatever data you give, Q will store the same data. That itself is D flip flop. Okay. Now until you keep this off and this on, okay. Here D bar will be present. Here D will be present. Will be present or it is stored. This itself is D flip flop. Alternate circuit representation. Alternate circuit representations. Alternate circuit representations. So this is just like theory. From theory, first one is behavioral. So theory, I think. Let it be. I'll explain. Behavioral style or circuit representation. ಇದರೊಳಗೆ ಏನಿರ್ತದೆ ಅಂದ್ರೆ just now we saw this memory. Okay, so if LD is 1, Q bar is equals to D bar. This is just I am writing a code. Okay, this code is what it is doing. It is showing how the circuit behaves. Okay, so this is alternate circuit representation. One circuit na hang represent ಮಾಡಬಹುದು using code we can represent. But illi the user or whoever sees this will sort confuse ಆಗ್ಬೋದು. Suppose ಅವನು D flip flop ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಬರೀ ಮಕ್ಸ್ ಅಷ್ಟೇ ಗೊತ್ತಿತ್ತಂದ್ರೆ ಅವ್ನು ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬೋದು. ಓಕೆ, ಮಕ್ಸ್ ಒಳಗೂ ಸಿಲೆಕ್ಟ್ ಲೈನ್ ಇರ್ತೈತಿ. ಸೊ ಸಿಲೆಕ್ಟ್ ಲೈನ್ 1 ಇತ್ತಂದ್ರೆ ಆನ್ಸರ್ ಇಸ್ D bar. So do one mux. Okay, ಇದು U bar ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಇದು D bar ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ D ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಅಥವಾ E ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಇದು LD ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಹಿಂಗೂ ತಗೋಬಹುದಿಲ್ಲ, ಇದನ್ನು ತಿಳ್ಕೋಬಹುದು. code. So this is not clear. It is just telling the behavior of the circuit, whether it is the flip-flop or particularly mux or any other thing. Don't know. We don't know. But circuit ಹೆಂಗೆ behave ಮಾಡೋದು ಅಷ್ಟೇ we are representing. This style of representation is called as behavioral style of representing the circuit. ಇದು ಒಂದೇದು. It is not very clear. Okay, just behavior ಅಷ್ಟೇ ಹೇಳ್ತದೆ. Second one is structural. Structural means it will tell, say I write a code for inverter. It has input, output, VDD, ground, PMOS, NMOS. So here PMOS is connected to input, VDD, output. NMOS is connected to input, ground, output. Just is the exact code ಬರೆದಿಲ್ಲ. Just this code is actually representing the structure of inverter. So PMOS is connected to VDD and input, okay, and output. NMOS is connected to input, ground, and output. So this code is actually representing the structure of the circuit, but not exactly. ಯಾಕಂದ್ರೆ ಈ ಕೋಡ್ ಒಳಗೆ ನಾನು ಮೆನ್ಷನ್ ಮಾಡೇನಿಲ್ಲ. ಇದು ಡ್ರೈನ್ ತಗೋಬಹುದು ಕೆಲವೊಬ್ರು, ಇದು ಆಕ್ಚುಲಿ ಸೋರ್ಸ್ ಇರ್ತದ, ಹೌದಾ? ಸೋರ್ಸ್ ಇರ್ತದ, ಬಟ್ ಇದ್ರೊಳಗೆ ಮೆನ್ಷನ್ ಇಲ್ಲ. ಸೊ ಇದನ್ನು ಡ್ರೈನ್ ಇದನ್ನು ಸೋರ್ಸ್ ತಗೋಬಹುದು. But still, this representation is better than this representation, because at least ನಮ್ಗೆ ಹೌದಪ್ಪ ಇದು ಇನ್ವರ್ಟರ್ ಇದೆ ಅಂತ ಸ್ವಲ್ಪ ಅನಿಸ್ತದ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ. This is one way of representing. So I will not much compare between the styles, but one more style is there, that is physical way of representing the circuit. Physical way of representing the circuit, here we draw the layouts, or layouts are the best example for physical representation, where layout ಒಳಗೆ ಏನು ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಿ? ಆಕ್ಚುಲಿ ನೀವು ಲೇಔಟ್ ಯಾರು ಬಿಡಿಸೇ ಇಲ್ಲ ಅನ್ನಿಸ್ತೈತಿ ಅಂತ. ಯಾರು ಬಿಡಿಸಿರಿ? ಬಿಡಿಸಿಲ್ಲ. ಸೊ ಲೇಔಟ್ ಅಂದ್ರೆ ಆಕ್ಚುಲಿ ಇದೇ ಸ್ಕಿಮ್ಯಾಟಿಕ್. ವಿ ಟೇಕ್ ದಿ ಲೇಯರ್ಸ್. ಸೇ ದಿಸ್ ಇಸ್ ಮೆಟಲ್, ಸೇ ದಿಸ್ ಇಸ್ ವೈರ್ ಐತಿ. VDD ಮತ್ತೆ ಇದು PMOS ಕನೆಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ಒಂದು ವೈರ್ ತಗೋತೀವಿ ನಾವು, ಹೌದಾ? ದಟ್ ವೈರ್ ಇಸ್ ಟೇಕನ್ ಆಸ್ ಒನ್ ಲೇಯರ್. We will study that in module 2. Layout ಎಲ್ಲ ಕಲಿತೀರಿ, but let us assume this is one layer, okay, and here I have one more layer of VDD. Say VDD is like this, then MOSFET. So this is a MOSFET, okay. Then I have here output. So layer to layer connection or bit to bit connection, LA source, LA drain, everything will be mentioned very clearly. So this is source, this is drain, okay, this is connection and all. So this is actually physical representation of the circuit. So idrolaga ನಾವು each and every bit ಗೊತ್ತಾಗ್ತದೆ. ಸರ್ಕ್ಯೂಟ್ ಹೆಂಗೈತಿ ಅಂತ. Physical generally layouts are very good example of physical way of representing the circuit. So in textbook three ways are explained: behavioral, structural and physical. Behavioral it defines only the behavior of the circuit. Circuit ಯಾವ್ದೈತಿ ಹೆಂಗೈತಿ ಗೊತ್ತಿಲ್ಲ. ಎರಡನೇದು ಸ್ಟ್ರಕ್ಚರಲ್. Structure of the circuit is shown or explained, or we understand how the circuit looks like, structure. But in detail, we can understand only through physical way of representing the circuit. So these are the three different ways, or three different ways how circuit can be represented. Okay.